This review video contains two parts. The first part shows questions on simple linear regression, the second part shows questions on multiple linear regression. This scatter plot, taken from the first example in Chapter 8, presents four candidate linear regression functions, a, b, c, and d. Among them, line a provides the best fit to the data. Why?
Intuitively, function a appears to be the most suitable regression model, as it aligns most closely with the data points in the scatter plot.
Among the four plots, y, b, has the strongest correlation, a, has not.
Keep in mind that correlation means linear association. In a, x and y do have a strong association, but it is not linear.
Option 1 and Option 2 are two objective functions for quantifying the distance between model predictions and observed values. Option 1 is the sum of absolute errors, Option 2 is the sum of squared errors.
When comparing two objective functions, least squares is generally favored over absolute error in linear regression.
There are 4 reasons why least squares is preferred over absolute error in linear regression.
A. Least squares minimizes the sum of squared residuals. This leads to a closed-form solution using linear algebra. Absolute error minimization lacks a closed form, and requires iterative optimization, often using linear programming. B. Squaring errors produces a smooth, differentiable function, which is ideal for gradient-based optimization. Absolute error introduces non-differentiable points at zero, making optimization more complex and slower. In this slide, A, B, C are good properties for least squares method. D is a good property for absolute error.
For a simple linear regression model to be valid, these three assumptions should be satisfied.
For the linearity assumption, usually scatter plot is the tool.
For the second assumption, histogram is a tool to test if the residuals follow a normal distribution.
Another way to test this assumption is using QQplot, which is also popular to test normality.
The third assumption, constant variability, requires that the variance of the values along the x-axis remains uniform.
In the bottom panel, the residuals are scattered evenly around the horizontal axis at zero, indicating that the assumption of constant variability is satisfied.
Given the results for a linear regression, can you answer the following questions?
1. What is the regression equation? 2. How to explain R square 0.7779? 3. What are the H0 and H1 for t-test about bio-IQ? What is the p-value for the test? 4. What does the F-statistic test for?
The multiple linear regression model is defined in the page.
What are parameters? What are estimates of the parameters?
By minimizing the sum of squared errors, or SSE, the regression equation is obtained. Since Bj estimates beta j, you need to understand how to explain its role in the model. Pay attention to the two different confidence intervals about Y estimation.
The confidence interval is the interval estimate about the mean of Y. The prediction interval is the interval estimate for the individuals of Y.
How to select a good model?
Among the three goodness of fit measures, R-square and adjusted R-square are popular for traditional statistics, For machine learning applications, it seems the standard error of the estimate is very popular.
This is the formula for R square, an explanation of R square. This graph breaks down the differences between y hat and y bar, between y and y hat. What are H0 and H1 for the joint hypothesis on model? What is the test statistic? Here are 4 assumptions for the linear regression model to be valid.
The independence assumption means observations are not correlated, or predictors are not too similar. The other 3 assumptions are the same as the 3 assumptions in simple linear regression. Please make sure you can do regression analysis using Python code.